object in orbit. In this video, we're going to answer what is the period of an object in orbit. That is, how long it takes for an object to go one circle around the Earth. So from our knowledge of uniform circular motion, we know that the speed when you're in orbit is going to be 2 pi r, that is the circumference of this path, divided by the time it takes to go through the path, what we call the period. So we can very quickly solve for t and say it's going to be 2 pi r divided by the speed in orbit. In the previous video, we showed that v in orbit is going to be the square root of the radius times free fall acceleration. So let's substitute that in here, and we're going to get 2 pi r divided by the square root of r times g. I can plug in the numbers here already. However, I'm going to do a little trick just to reduce the number of r's that I have in my equation. And to do that, I'm going to multiply by square root of r and divide by the square root of r. So that is like multiplying by 1. But now square root of r in the denominator plus another square times another square root of r, that just gives me r, which is going to cancel this one over here. And now I only have 1 r in my equation, which is going to make things easier because I'm going to have 2 pi the square root of r divided by g, where r is the radius of my path in orbit. Again, we're going to use the same approximation as last time and say that this radius is approximately the radius of the Earth, which I'm already approximated, and 64 times 10 to the 5 meters. And I'm going to do the same approximation of, instead of 9.8 meters per second, I'm going to use just 10 meters per second. So then this period is going to be approximately 2 pi 64 times 10 to the 5 meters divided by 10 meters per second square. My meters are going to cancel, and my units are going to be second squared. With the square root, I'm going to be left with seconds, which matches my expected result. So I'm going to have approximately 2 pi square root of 64 square root of 10 to the 4, because I have 10 to the 5 here in the numerator and 10 in the denominator. I'm left with 10 to the 4 seconds. So this is 2 pi 8, and then times 10 squared seconds. Now 2 times 8, that's 16. And then instead of pi, I'm going to say that's approximately 3 times 10 squared seconds. So 16 times 3, that's 48 times 10 to the square seconds. Now to use a more familiar unit, let's change these seconds to minutes. So I need to divide by 60 seconds equal 1 minute. So that's seconds here. Cancel these seconds here. So I have, let's see, 48 times divided by 6 times 10 squared divided by 10. 6 times 10, that's 60 minutes. And 48 divided by 6, that's 8. 10 to the square divided by 10, that's 10. So I have 80 minutes. So it looks like for any object that is near the surface of the Earth in orbit, it's going to take it about 80 minutes to do one full cycle. In fact, the International Space Station, which is also not very far away from the surface of the Earth, has a period of 93 minutes. So in fact, we got a very good approximation for something that we can actually measure, like the period of the International Space Station.